Okay, so in section 3.4, we're going to talk more about polynomial functions. Now, a polynomial function looks like this. F of x equals, and then we can have a sub n, x to the nth, plus, and then there could be all kinds of terms, plus a sub 2x squared plus a sub 1 x to the first power plus a sub 0. Okay, that's the form of a polynomial function. We want the highest exponent first. That says highest. And then we want them to go in descending order. This is the general form for a polynomial function. Not all the terms have to be present. So you could have, like, 5x to the fourth plus 3x squared plus 7. That would be considered a polynomial function. The highest exponent here is 4. And so when we write these in general form, we need to make sure the highest exponent is first. These subscripts on A, they're just to help you keep track of which term has which coefficient. So like in this case, 5 would be the a sub n, or a sub 4, and 3 would be a sub 2, and 7 would be a sub 0, or sometimes I'll pronounce that as a naught, okay, but a sub 0. Okay, so what we want to do is look at the behavior of polynomial functions, the local behavior. Now, we have had some polynomial functions. We had the constant function, okay, and in that case, n is equaling 0, right? So if you think about, on this last term, having an x, it would be to the power of 0 because x to the 0 is 1, and then that would just be a constant number, okay? So, it's a function. You could think about it as a polynomial function, but we really refer to this as the constant function. F of x equaling x. That's when n equals 1, and that's a linear function. And we've talked about linear functions. F of x equaling x squared, well, that's n is 2. That's a quadratic function, and we talked about those in this chapter already. We're interested for polynomial functions. We're interested in them having n greater than or equal to 2. Okay? So we kind of know what happens with these functions, the constant function, the linear function, the quadratic function. Kind of know what's happening, what they look like, a line or a parabola. But now we're interested in a higher degree polynomial, okay? Now, n equaling 2, that's going to be quadratic. But all right, characteristics of polynomial functions. Polynomial functions are going to graph to be smooth, continuous, we usually say curves, smooth, continuous graphs. So what do we mean by a smooth graph? Well, a smooth graph, let's say you have a graph that's like this, that's considered a smooth curve. It just has these kind of rounded shapes here. Let me put it in a different color. Rounded shapes here as we're going from increasing to decreasing. It's kind of rounded like that. So what isn't smooth? This is smooth. Something like we've had graphs like this, where there was a sharp corner. That's considered a sharp corner, and it's not smooth. So this one is not smooth. You could also have something like, a graph that comes up and then like goes constant, right? So it's linear and then it goes constant. This would not be smooth. So that's another sharp corner, and this is not smooth. So it's not a polynomial graph. Okay, so no sharp corners. Polynomial functions, they graph, and they don't have sharp corners. They're smooth curves. Okay, now what do we mean by continuous? So a continuous curve, not sure what that is. A continuous curve is one where if I have this graph, I can trace it without picking up my pencil. So when I trace this curve, I start here and I can follow it all the way through. There's no breaks. So no breaks. That means it's continuous. But if I had a graph like this, and we've had graphs like this, maybe it comes up here, and then maybe it jumps up here and goes this way. When we were doing our piecewise functions, we had things like that. This is not continuous. Not continuous. You can't trace it without lifting your pencil. So you can go up here, but then you'd have to pick up your stylus and move it up here to continue tracing it. So if there's a break, it's not going to be continuous. A break in the graph. Okay, so polynomial functions, again, they graph to be smooth, continuous curves.